All right, guys, we are going to move into 3.3 at this point. There's one thing I would like you to change, simply because it will help aid our understanding for dividing polynomials. That thing I would like you to change is this 144 divided by 16. If you guys could change that to a 143, I want it to be a problem where it just doesn't work out as nicely as 144 divided by 16 does. Just want us to remember the process of long division, what the different numbers are called, and so on and so forth. So if you have a problem like 143 divided by 16, which one do you put underneath the divide sign? 143, good. And what number goes on the outside? 16. Now, does anybody remember the terminology, what 143 is called and what 16 is called? Dividend. Yes. Dividend. What's this one called, 16? Divisor. Nice. Look at you guys, all stars. Okay, we'll keep going and then we'll take a look at what the others are called. Yes. Okay, so looking at 16 divided by 143, first you look at the first two numbers and say, does 16 go into 14? No. So then you're looking at how many times does 16 go into 143? Anybody know the amount of times that we can multiply 16 into 143 evenly? 8, yeah. 8 times 16, that's 80 plus 48 gives us 128. What's the next step in the process of long division? Subtract, good. And we get a remainder, borrow from the 4. 13 minus 8 gives me 5. 3 minus 2 gives me 1. And what is that thing called? Remainder. Remainder. And what's the number 8 called? Quotient. Yes, you guys are awesome. Quotient. Now, you may have been able to just say, this is 8 with a remainder of 15. I don't want you to write it in that way anymore. Instead, your answer, you can write in two ways. Sorry. You could write it as, so let's go ahead and let's just say what we did. 143 is equal to 8. Actually, no, I'm going to do that second. Sorry, if you guys could erase that. This is the way that I would prefer you to write it in most cases. 8, and then the remainder goes over your divisor. 8 and 15/16. Did you guys know that you could write it in that way? Did you have to write it in that way when you were doing long division before? So essentially what you look at is you always write your remainder over your divisor, and that will tell you the fractional piece that's left. If you looked at your calculator and did 15 divided by 6, if you did 16 times 8 and 15/16, you would get that 143 answer. Or we could take 143 divided by 16 and you would see 8 and a decimal. That decimal would actually be 15/16. Some mathematicians even will write this as 8 and a remainder of 15/16. The other way to look at it, and this is the second way to look at it, is seeing that 143 is equal to the result of 16 times 8 plus 15. Now I want you to just write both of those ways, simply because it will show you the two ways to write your answer when we start working with x's and x squareds and such. Okay, now let's go ahead and let's take a look at example 2, how we can do this with two sets of polynomials. You guys have seen that when you have a polynomial in factored form, it's really nice to graph. So our goal in lesson 3.3 is to be able to take any polynomial and factor it down, and long division is one of the tools that will be available to us to factor it down so that we can go ahead and graph it quickly and see features of the graph. Okay, so which one is the dividend? Which one goes underneath the bar? The x minus 4 or the big trinomial? Yep, the 6x squared minus 26x plus 12. And we're dividing that by x minus 4. Okay, now I know that you had to do this in Algebra 1, but it's probably been a while. Let's review, how do we do this process? So in the same way that you did the previous long division, you're looking at the number on the outside and seeing how many times does it go into the number inside. Because we have multiple terms, we're just looking at the first term on the outside and the first term on the inside. And you're asking what times x would give me a 6x squared? What would be the answer? 6x, so we put it on top. But now we have to make sure to distribute the 6x to both pieces. So 6x times x would give me 6x squared. 6x times negative 4 would give me negative 24x. But now what was the next step in the process of long division? Subtract. How many pieces am I going to subtract here? 2. So I'm no longer subtracting one number, I'm subtracting both. If you want to group them in parentheses, because we have two terms, then you can put the negative on the outside and then use it to distribute. But you need to make sure that when you subtract in the process of long division, you subtract both terms. Now, 6x squared minus 6x squared, that's 0. That will tell you that you did that correct. Negative 26x plus 24x, what will that become? Negative 2x. And then we bring down the 12, and the process starts over. So you look at just the first term on the outside and the first term that you're dividing into on the inside. And you ask, what times x would give me a negative 2x? Negative 2, so we put that answer up. What do I need to remember to do with that negative 2? Distribute, so I have negative 2 times x, which would give me negative 2x. Negative 2 times negative 4, which gives me a positive 8. And then what would be the next step? Subtract. How many terms? 2. I'm going to subtract both. So if you want to think about putting the negative on the outside, or if instead you just want to subtract both terms right away, what happens when you minus a negative? Positive, and then here would be a negative 8. So now negative 2x plus 2x is 0. 12 minus 8 would be 4. But what is this piece called again? Your remainder. There's two ways that I want you to get in the habit of writing this. So the two ways are similar to what you saw over here to the left. The first way would so let's go ahead and let's put our answers. The first way would be use your quotient, which is 6 minus 2. And you would add that to your remainder, which is 4, over your divisor, x minus 4. Now mathematically, what you need to see, and this is why I would ask you to write it in the second way, the second way would be seeing that 6x squared minus 26x plus 12 is equivalent to x minus 4 times quantity 6x minus 2 plus your remainder plus 4. Now, why is that so helpful? I love checking my work. I tend to make simple mistakes. And when I have something I can check, if I have the time to do it, I do it. Just to make sure, hey, did I make any simple errors along the way? With all these minus, negatives, and double terms, there's definitely areas you can make a mistake. But this will help you check it. If I multiply the divisor by the quotient and add the remainder, I will get the number underneath the bar. Any questions on that? Okay, so what we just looked at here, is what you will see as the division algorithm in your book. This is the way the division algorithm looks. It says that the dividend, the number you're dividing into, is equal to the divisor times the quotient What do you think I would add to that? Plus the remainder, exactly. Plus the remainder. You might see it in function notation, the division algorithm, so just so you know what this is equivalent to. Sometimes the dividend is called p of x. So the polynomial that you're dividing into is equal to the divisor, d of x, times quotient of x, plus your remainder, r of x. Now, you don't have to memorize it in function notation. You just need to memorize the division algorithm or how it works, so you are always ready to check your answer. Any questions about that so far? Okay, let's try one where you might have some terms missing. So what do you do when a term is missing? Well, first of all, look at this division problem. Where is the term missing? Do you guys see a term that's missing? The x to the, well, we have an x to the fourth. It's the x cubed. Yeah, sometimes those are tricky and you don't always see them. So what we do when a term is missing is you just add it in as a placeholder, 0x cubed, just so you don't get lost in your work. So let's do this together, see how this one works, and then I'll have you try the next one with your partner. So the number underneath the bar would look like 8x to the fourth plus 0x cubed plus 6x squared minus 3x plus 1. And again, the polynomial under the bar is called the dividend. And we're dividing that by 2x squared minus 8x, or minus x, excuse me, plus 2. Again, we focus on just the first two terms. So the 2x squared and the 8x to the fourth. What times 2x squared would give me 8x to the fourth? 4x squared. Good. What do I do with that number then? Distribute. So distribute this back through to, now this case we're going to have 3 terms. So 4x squared times 2x squared would give me 8x to the fourth. 4x squared times negative x would give me negative 4x to the third. 4x squared times 2 would give me 8x squared. And then what do I do with all of those? Subtract. Make sure you subtract all of them. So the minus and negative creates a positive, and the minus 8x squared. Add straight down, so these cancel. 0x cubed plus 4x cubed would give me 4x cubed. 6x squared minus 8x squared gives me negative 2x squared. And now we have 2 other terms to bring down. So I'm going to bring down the negative 3x and bring down the plus 1 and just carry them through in the problem. Yeah, go ahead. Why don't you guys finish this one with your group? Some conversation, see what you guys get. Write your answers in both ways, and then we'll discuss what the answer is as a group. Okay. That's fine. All right, guys, how did we do? Any questions on this process so far?
You have to write it both ways.
Just for practice, yeah, just so we can see kind of both answers in the way that they look. Probably in the back of your book will match this way. But I like you just being in the habit of at least writing maybe the first 2 in that way so you can see how you could check the answer. All right, let's go to the next one. Any missing terms, or are we good? There's no constant, so we'd want to maybe add a 0. Anything else?
0x.
Yeah, there's a 0x here in the divisor. So let's go ahead and let's set this up. Actually, do you guys want to try this one on your own and then we'll check it? Or do you want to do it together? Let me ask a person. Garrett, try it on our own or do it together? Okay, all right, let's do it. I like to talk while I work. Here we go. 6x cubed plus 2x squared plus 22x plus 0 divided by 2x squared plus 0x plus 5 Okay, start with just the first terms. So what times 2x squared would give me a 6x cubed? A 3x, good. Distribute that through, so 3x times 2x squared would give me 6x cubed. 3x times 0x, what would that give me? 0. I don't need that. If you want to, you could say O plus 0x squared, because anything times 0 is 0. 3x times 5, what would that give me? 15x. And what do I need to do with each of those terms? Subtract, subtract, subtract. So 6x cubed minus itself is 0. 2x squared minus 0x squared would maintain the 2x squared. 22x minus 15x would give me 7x. And then I'm going to bring down that 0. Process repeats itself. What times... Whoa, hold on, Jeremiah. No, yeah, interrupt me, please.
So, like, I don't get, what's the point of, like, having that 0?
You don't need it. It's not necessary as long as you see. Some people, the only reason I put it in is because when we first start doing this process, I notice some people, if they don't have the placeholder, they just get lost with their x's. So I like having it for instruction purposes so you can see that it's just a nice fact that, okay, there's no x squared, but I know that I still need to work with the term above it. So if you don't like the 0, you don't need to put it in there. Just don't get lost in your x's. Make sure that when you do 3x times 2x squared, it goes under the x cubed. And make sure when you do 3x times 5, which would give me 15x, I would put it here, which means I would have nothing show up right here. You see what I'm saying? So do I need it? No. But I want to make sure that I don't lose my place. Because when I multiply 3x times 5, I end up with a 15x.
So the missing term is the placeholder?
Yes.
Okay.
The missing term is the placeholder. Excellent. Okay, cool. All right, so if I keep going, thank you for asking and clarifying that. Now keep going. 2x squared. What times 2x squared would give me 2x squared? 1. Now, if per se I didn't have this here, I would just need to make sure that I take into account of where my numbers go. So 1 times 2x squared would give me 2x squared. And then 1 times 5 would give me 5, but that would end up over here if I didn't have that 0x. And then I would subtract. This cancels, but I don't want to forget about that 7x if I'm not using a placeholder of 0. So 7x plus nothing is still 7x minus 5. And then what is this piece here? Remainder. So our answer would be, if you're looking at the first form, 3x plus 1 plus 7x minus 5 over 2x squared plus 5. Or quantity 2x squared plus 5 times 3x plus 1 plus the 7x minus 5 is equivalent to my answer. I always mix up those names. To my radicand. That's what it's called.
We have to write
No.
the first one first.
The first one is going to be the one that I would ask you to write on quizzes and tests. The second one is just so that you can check your answer. Because if and actually this is good even for me to do, if I FOIL this out, then I would get 6x squared, or sorry, x cubed, plus 2x squared, plus 15x, plus 5. And I know I'm adding this to my remainder, 7x minus 5. So that would give me 6x cubed plus 2x squared plus 22x plus 0, which I can see doesn't match that, and it does. So it's just a really nice check step to say, hey, did I do all my stuff good? Does that help? Just to see that? That was my plan.